Everyone, and welcome to our project 8 or 3, the multi-language sign recognition system. My name is Ami Yadav.
I'm Spencer Wilson.
So let's get started. There are about 300 plus sign languages throughout the world, and depending on the demographics of the country, there tend to be different signs for every languages, as similar to like simple spoken languages. So to show you the differences, we have a statement, where is the bathroom? In American Sign Language, it is.
However, in Indian Sign Language, we say, where is the bathroom?
There has been a collaborative and tons of work already done in sign language to spoken languages. There are different methods used, as people use electronic gloves to detect the gestures and even connect cameras to detect the signs of the language itself. On the right image, you see there are tons of countries mentioned. It's a whole hub which has been working for the past 20 years to translate a sign language to a spoken language. But there are no works done in from one sign language translation to another sign language translation. So that's where we come in. We started with a small set of images called the data set. We took the American Sign Language and the Indian Sign Language. Given the time frame, we start off doing just the number system itself. So in the screen, you would see the American Sign Language from 0 to 9 and the Indian Sign Language from 0 to 9. The next step was to make the image comprehensible for the AI to function well. So on the leftmost side, you would see an original image of a sign language number 2 for ISL, which goes through a process which tends to detect just the edges of the images itself. So you see the white border around the number 2. And the rightmost image, which you see, is the small little red galaxies. It's just a huge mathematical mumbo jumbo, and ultimately we see the canny for your image.
Building on that, we used a base model called VGG19, a popular AI machine for working on images and other tools. We also used the ImageNet pre-training weights for this. We ran 4 experiments. We started by considering those galaxy images, pre-processed images. What if we fine-tune and transfer learn that on our VGG19 with ImageNet? Or what if we take those galaxies and we just transfer learn? We then took a step back and said, well, what about the original images? Did we need to do this pre-processing? Putting the original images in, fine-tuning and transfer learning, or putting the original images in and transfer learning. For us, we found the best results on the original images only with transfer learning. However, that pre-processing should still be considered in future experiments for larger data sets, different sentences, words, and so on. Let's take a look at our architecture. If I give you an ASL sign for 6, if I give it to the machine, it goes to the language classifier and it says, it performs fancy math and says, oh, that's definitely American Sign Language. Because it is, it's going to pass that same image across the bottom to the ASL semantic classifier, and it's going to say, hey, what's the number for this? Oh, this is a 6. Great. It then considers, we were in ASL 6, I now need ISL 6, and it'll give me the number for 6 in ISL. Next, I have a brief programming demo for you. Consider here, I'm going to work on the number 8. If we execute this, it was expecting ASL and correctly identifies it. It was expecting 8, it correctly identifies it. It takes very little time, and it's able to say, given ISL 8, give me ASL 8. This code is publicly available on GitHub at the link shown here. Future work could involve a robotic translator or a virtual assistant to work on sentence-level explanations. a special thank you to Dr. Donna Garari and the team.